Good morning, world. Today we're going to talk about something that is very near and dear to my heart. There is a false paradigm that when you go or use quantum encryption, that you're going to suffer, that your performance is going to suffer, that your network will suffer, that your costs will suffer. That's not true. So Project 11 just did a test with Solana. The test came back and it showed that you do suffer. Okay. So Solana had a 90% degradation in their performance when they added post-quantum encryption into the blockchain. And I think they were just wrapping with FHE, kind of standard stuff. So what happened? It's not an issue with the technology. It is an issue with engineering, and I will prove it to you today. So let's see if I can figure out how to show off my screen. Are you guys ready to see some good news? Some good news for those out there, because if you don't have a solution that can scale, if you don't have something that's going to be fast, you're going to be waiting for a long, long time. It'll feel like you're on dial-up internet, and that's not going to be fun for anybody. That's going to happen. All right, let's see. Boom, there we go, share. Okay, so you're on a website right now. Let's go to live test. Put in my email address with Cashy. Use Cashy, they deserve. So that's a live test that you just saw. Let me do it again. Let me actually open up the network window for this one so that you can see the test live. Down here, show our work. Run it again. Speed test. So this is showing the real network right here now. So here's the actual test in here. What you just saw is a full authentication of FHE BFV 128, which is post-quantum, our ZK Stark lookup, which is post-quantum, and dilithium, which is also post-quantum. I believe we also, we did. We ran biometrics in here as well. So we're actually running the biometrics in addition with the FHE. So that is a full scale, we call full stack, post-quantum with 1,000 real auths. And it ran at about 13,100 authentications per second. Now, we're doing 2.2 million. So you might ask, well, what happened to the 2.2 million? This is running through a browser with a single channel, okay? This is not a production stack. This will run one channel, whereas our production stack runs 96. This runs at about 13,100, 13,200 auths per second. Our production stack runs 22 to 23,000 times 96, which gets us to the 2.2 million per second. So these are batched and these are real. And what we just proved right here on this is that you don't have to sacrifice speed and performance. Matter of fact, we can add post-quantum to your existing infrastructure and potentially make it faster. So these different pieces down here, which you're looking at with 34 microseconds, that is what sits on your server. So once we wrap it, it becomes ciphertext. This is the load that sits on your actual server, meaning this is light. It's not going to add a bunch of extra server fees to it too. So the myths previously were that post-quantum was going to be slow. You can see that it's not, probably faster than your current network. That's the joys of both patching and engineering. Second, that it was going to be heavy sitting on your network, that you were going to have to incur extra costs. The answer there is no. Also, that you were going to have to transition away from your current infrastructure to some specialty infrastructure. Also not true. The other couple myths is that that switching to post-quantum requires many years and tens of millions of dollars, We converted a mortgage company last week in 7 minutes, full post-quantum. And so no, it doesn't. It's a drop-in API. I mean, you're just calling an API from the outside. Everything's wrapped. Nothing touches our database. We don't see the data. The data is encrypted. Your ends that you have, your points of failure that you would have, your risk factors that you have are identified and converted virtually instantly. And next thing you know, you're full post-quantum. Well, what does that mean? Does that mean that your whole life changes? No, I've been post-quantum for a few months. There's not one single change. I don't notice a thing. My documents still open because I have the keys to open them. When they're not open, they're encrypted, so nobody that gets into my database can steal them. It's pretty basic stuff. So the main myth today, and you're seeing it, let's run it again. Let's run it one more time so we can see it over here. There it's running again. You're seeing 1,000 real loss. Here's your speed. It is repeatable. This is in production. The production runs at 2.2 million transactions per second, which is your full authentication, which includes, again, your FHE, your ZK Stark. We have 2 Starks. We have lookup and we have air. And then finally, your key. We're running 1 key here. We're running dilithium. But we also have the 3 key, which are 3 different math families. That way, if somebody does happen to break lattice, which doesn't appear like it's going to happen anytime soon, but if they do, or if there's a backdoor into lattice, there's 2 other mathematical families that you also have to break at the exact same time. The odds of that are pretty much 1 over the universe, or maybe bigger than that. So it's not going to happen. But we built it anyway. And if some point the machines get better, stronger, faster, we can just add more keys. We'll add more mathematical families to this and be able to keep you safe and secure. So that's really easy to do as well. So I hope you enjoyed the demo that showed definitively that no, post-quantum won't make you slower. No, it's not going to take forever. No, it's not going to cost millions. No, it's not hard to implement. No, I don't need to go out and hire cryptographers and load up my staff with mathematical experts. Everything that you've heard is completely false. All you have to do is call the API. We are in the Microsoft Amazon Web Services store right now. So you can just drop it in, call right from inside your stack, inside AWS, and be post-quantum to that. Enjoy. Hope everyone has a nice day, and we'll do this again real soon. Thank you.